Hi, welcome back to my YouTube channel. In this video, we are going to learn about authorization models. This video is part of authorization series. In this video, we are going to learn about three authorization models. They are RBAC, ABAC, and ReBAC. And at the end, we are going to compare all of those models to see the strength and weaknesses. So the first part is about role-based access control. When I was learning about this matter, I was curious about the difference between ACL or access control list with RBAC, I mean. So access control list is a authorization system that can grant permissions or restrictions to individual users. So the keyword here is to individual users. So you assign the permission or restrictions to individual users. This is great, especially if you want to build a system that can restrict individual users to do some actions in your applications. But it's not so great if you want to use it for granting permissions, especially if the number of the users are a lot, because you need to assign one by one. So ACL does not scale well for a large number of users. Therefore, it's preferable to use role-based access control or RBAC. So RBAC is authorizations model that based on roles. So we define the roles. So the components of RBAC are user, roles, permissions, and capabilities. So for the illustrations, we have users. Let's say these users require capability to access some data to do something with the applications. Because of that, we can assign them roles. So we define the role first. In this case, we have three roles with name admin, dev, and reviewer. Each of the roles has permissions, in this case to read or write, to specific resources, app 1 or app 2. So let's see another example. This is an example in Kubernetes. So let's say there is a user named John. He needs to check pods status in the Kubernetes for his work. Therefore, in this case, we can create a role with name pod reader, and then it can give a get or release permissions to pod resources, and then we can assign that permissions or role to user John, right? So this is one of the example of role-based access control in Kubernetes. And to implement RBAC, we usually group the requirement based on the job conditions. So the role usually define group based on work locations or duties or department or seniority level. And then based on those rules and permission, it determines what access user can have, what action they can do with their permissions, and how long they can have the permissions. And to implement this, National Institute of Standards and Technologies created 4 levels of RBAC that we are going to discuss in the following slides. The first level, it calls flat RBAC. So in this level, basically, a single user at least will have one role assigned to that user, and if it's required, we can add more roles. And then in terms of user assignment, one user can assign to more than one roles, and one role can be assigned to more than one users. So the assignment here is many to many. It is the same with permission assignment. Roles, one role can have multiple permissions, and one permission can be set to multiple roles. So the permission assignment also many to many. Level 2 is basically level 1 plus role hierarchy conditions. So with the role hierarchy means that we define the roles based on seniority level in that organizations. Based on seniority level, we can set different role and permissions. And we can draw the model using tree. For example, we can use an inverted tree. So in this case, the junior most level is engineering department, and this level is the senior most. And with an inverted tree hierarchy, we can share resources. For example, everyone that is in engineering 1 and engineering 2 can share resources with engineering departments roles and permissions. And then we can also use a normal tree hierarchy if we need to aggregate the roles and permissions, because only using inverted tree we cannot do aggregations, but using tree hierarchy we can aggregate the roles and permissions. For example, project lead can have both production engineering 1 and quality engineering 1 roles and permissions, so we aggregate in one roles. Of course, if it's required, we can combine both methods like this. So now we can share the resource and also aggregate the resource. And again, it depends on the policy of the organizations. We can also omit the junior most and the senior most roles or permissions, right, if it makes sense for that organizations. In creating the hierarchical RBAC, there is a thing called limited inheritance. To illustrate that, on the left there is a tree hierarchy. In this case, project supervisors has test engineering and programmers permissions. So sometimes it's too dangerous for someone having too much power in the organizations, even though maybe they are trustworthy, but still there is a risk for the user to do some fraud or something like that, right? So therefore we can create what we call private or internal roles or permissions. So in this example, test engineer over here is a placeholder of the test engineer role and permissions, there are some resources that maybe we can share to project supervisors, but for critical permissions we will put in this test engineer role permissions with a tick, right? So now project supervisor technically will not have all of the test engineers role and permissions, right? That's what limited inheritance is. Level 3 is level 2 plus separation of duties constraints, especially when we determine the user assignment and role hierarchy. So what does it mean? It means that let's read together, okay? So separation of dati refers to the partitioning of tasks and associated privileges among different roles to prevent a single user from garnering too much authority. So it is if you read the definitions, it's something similar with what we have discussed before, which is the limited inheritance. But in limited inheritance, we prevent this by playing around with the roles and permissions assignment, right? By creating private permissions. But the approach of constraint RBAC is a bit different. We'll see that later. Okay. So why we need to do this? Yeah, to avoid conflict of interest and also to avoid fraud and major errors. So we create a policy that preventing fraud or major errors can be happened with a single user. By a single user, at least they need to find a partner of crime to do fraud and major errors with different roles and permissions. So for example, we have Alice and Bob. Alice has engineer roles, Bob has QA engineer roles, and engineer roles has permissions to modify application source code, and QA engineer has permissions to create a test. So we want to avoid a user having both roles, right? Why? Because user having both roles, they can create some applications, can modify the source code, and then they can try to bypass the task, right? So the application source code can be deployed to productions, and we don't know, maybe they put some dangerous codes or some malware or some backdoors. So with separation of duties, we can ensure that one user should not have both engineer and QA engineer at the same time, for example. So level 4 is symmetrical RBAC, is everything in level 3 plus permission role review. Permission role review is basically a way to manage the permissions periodically, right? Review them, audit them, and adjust the permissions if it's required based on the condition of the organizations, and to effectively react to change and modify permission role relationship accordingly. So for example, if I was working at engineering division, but let's say next week I move to QA engineering divisions, then when I switch, permission role review is to ensure that everything that I need, permission that I need, is there when I start my QA engineering role, and then it is also to ensure that the permission that I used to have should be removed from me. All right. So the next model is attribute-based access control. So this is a model that relies on conditions of the attributes. So the policy, the decisions to grant the permission or not is based on attributes. So what attributes? First, it can be from the user attribute itself, like for example name, role, clearance. Attributes from the action itself, like the type of the action, the number of the actions, the rate of the actions, and so on. It can be from the resource attributes, for example the name of the resource, like a file name for example, the date, the size, and etc, etc. And also from the environments, like when we do that actions, where we need that permission, and etc, etc. So all of these four components will determine the final results by the authorization policy. So for example, here we have an NLP, a natural language policy, allow known customers to place up to 3 orders from a local store outside of opening hours. So with this NLP, we can try to create the models using ABAC. Let's say we have these attributes of user, action, and resource, and then we can determine the policy. So allow known customers, so customers is the users, known is the attribute of the user, so the user need to be verified, to place up to 3 orders, so the action is order, and 3 is the count, right? From a local store, so store is the resource, local is based on the city, right? The city of the store need to be the same with the city of the users outside of opening hours. So opening hours is the attribute of the resource itself. So by having these attributes, we can decide whether these actions should be allowed or not. The last model is relationship-based access control. In this model, the policy is focused on the relationships, right? Or how resources and identities like users are connected to each other and between themselves. So for example, on the left, there is a RBAC example. For example, if there is a user with a VIP role, right, then we can grant him permissions to dance, to order drinks, and to access the lunch, okay? But using relationship-based access control, a user will only have one like permissions to access VIP lounge, all right? And then in this example, assuming that dance floor and VIP bar is inside the VIP lounge, therefore we can assume that whoever has access to VIP lounge can also dance on the dance floor and order drink on the bar, right? So the guest only has one access, like one permissions, and the other is determined by the relations of this resource to another resource. So this model is used heavily on like file systems, like in the Google Drive, something like that. We'll see that example later, right? And this kind of models is very easy to visualize as a graph. So therefore there is a thing called graph-based authorization systems that we will see on the next video, maybe in the third video of this series. We'll discuss about that. And there are two common relationship types that I want to discuss. The first one is parent-child hierarchies, and the second one is organizations. So in parent-child hierarchies, it describes the nesting of resources under other resources, right? So here, as I said before, it is like a file system in the cloud storage. Usually, if you are an owner of one directory or one folder, you will have access to every files that stored inside that folder. So this is what parent-child hierarchy is. So the parent is the root of the folder, and the child is everything inside that folder, right? If you are the owner, then you can like read, copy, do whatever. But if you only has permission to view, you can only view all of the files inside that folders. And the next types is organizations. In these relationships types, it allows you to create policies based on groups of users. So in this example, Bob, Sam, and Linda is a member of group HR group, and everyone with that group, inside that group, will have an editor access to legal documents and employee data resources, for example, right? Something like that. So let's compare those three models. So let's start with the use case, right? So for RBAC, it allows us to create policy based on roles without having to manage permission per individual users compared with ACL. And in ABAC, it allows us to create policy based on attributes of the user, of the resource, of the actions, and based on the attributes of environment. And in ReBAC, it allows us to create policy based on the hierarchy and the relationships. In terms of granularity, in RBAC, it's limited granularity because the policy is based on roles that we define, right? To have a better granularity, if you need a better granularity, you need to switch to either ABAC or ReBAC, right? So ReBAC has higher granularity than RBAC, but not as granular as ABAC. So in terms of complexity of the implementation and management, RBAC is the lowest, is the easiest to audit and to set up. And for ABAC, I would say it's challenging. It's more complex than RBAC because there are so many maybe there's so many attributes that you need to check, right? And for ReBAC is also very complex because it's based on relationships, and there is like a recursive nature of RBAC itself. So in terms of complexity, is the highest. About the performance, RBAC should have generally high performance due to the simple policy executions. For ABAC, because again we need to manage these attributes, and usually these attributes are dynamic attributes. They can change, and we need to capture real time those changes. So in terms of complexity is complex, and performance is maybe is not as great as RBAC, but if we decide it correctly, the performance can be okay, right? For ReBAC, for data mapping, it's usually easier, right? But the recursive nature of relationships can produce inefficient queries. So all of this we will try one by one, creating policies based on these models in the next videos. All right. But yeah, for this video, this is the final slides. I hope you enjoy the content so far. So keep learning and stay healthy until the next video. Bye bye.